So we begin with the seventh problem in the collision mechanics series, and this is problem number 1.171, and the question is stating a shell flying with a velocity of 500 meter per second burst into three identical fragments so that the kinetic energy of the system increases to 1.5 times. What maximum velocity can one of the fragments obtain? So as we begin this problem, let us first of all draw a necessary diagram to explain the situation. So this is how we can explain the situation which the problem is describing, that a particle of mass 3m which is originally moving with 500 meter per second burst into three fragments of equal masses flying like this: v1 velocity in the forward direction and v2 and v3 in the backward direction. Now one thing that we need to understand is that the problem is asking us to calculate the maximum velocity which one of the fragments can obtain. So in order for v1 to be maximum, so over here we are considering this scenario, so we can say that there is no momentum in the y direction. So initial momentum in the y direction must be equal to the final momentum in the y direction. So initially there is no momentum at all in the y direction. So finally also there must be no momentum in the y direction. So if I consider v2 as a cos theta and then v2 sin theta, so we can write m v2 sin theta, which will be in the upward direction, is balanced by m v3 sin theta in the downward direction. And from here we can say that the value of v2 is equal to v3. So the magnitude of v2 and v3 must be same. Now one more important aspect which must be kept in mind is that if we want v1 to be maximum for v1 to be maximum, which is the need of the question, the other two particles must fly in the backward direction. Must fly with theta being 0 degree. So we can say there is no idea about y-axis motion. Both the particles must be going towards the negative x direction so that v1 can be maximum. This idea is very simple to understand if you have solved enough problems on momentum conservation, that if this particle is heading in the forward direction, then for momentum to be in the x direction, if the other two particles are having momentum in the negative x direction, so this particle will attain a maximum velocity in the x direction to compensate for the velocities in the backward direction. So this basic idea which we are using to approach the next step for the problem. So we can say that the three particles involved, one with a mass m, other also mass m, and the third particle which was moving with a velocity v1, which we are maxing out. So we can say that these two particles must be moving with identical velocity. Let us say v2 in the backward direction and v1 need to be in the forward direction for v1 to be maximum. So this is the scenario that we obtain. Now what we do is we apply momentum conservation in the x direction. So initial momentum in the x direction must be equal to the final momentum in the x direction. So initial momentum in the x direction is 3m mass moving with 500 meter per second, and for the final case we say minus 2m v2 in the opposite direction plus mass m moving with a speed v1 in the forward direction, and this serve as equation 1 for this particular problem. Now the problem has also stated that the final kinetic energy is 1.5 times of its initial value. So if we calculate the initial kinetic energy, so we write kinetic energy initial, and this is equal to half 3m and then 500 squared. And if we calculate kinetic energy final, So the final kinetic energy is half 2m moving with velocity v2, so v2 square plus half m v1 squared. Now this final kinetic energy is 1.5 times its initial value, so it is 1.5 times half of 3m 500 squared, and this will be serving as the second equation for this problem. And on rewriting this expression, we obtain an equation like this, that v1 square plus 2v2 squared is equal to 1125,000. So this is the modified second equation that we have. So we have the first equation, which is this one, momentum conservation, and the second is from the kinetic energy aspect, where it is stating that final kinetic energy is 1.5 times its initial kinetic energy. Now if we solve these expressions, so we can cancel out all the m, and then we substitute the value of v2 from this expression over here to make a final quadratic equation in v1, because we are calculating maximum value of v1. So we can directly head to calculate v1, and on solving we obtain, so on solving, I'm leaving the mathematical part for students, this is simple quadratic equation. So on solving we obtain v1 is turning out to be 1000 meter per second, which we can also write 1 kilometer per second. It is too much of a velocity. And the v2 is turning out to be in the opposite direction, the direction which we have already chosen, as 250 meter per second. So this is the final answer for this particular problem. Please keep in mind that v2 will be having a value 250 meter per second, and v1 is having velocity 1 kilometer per second. So this is the final solution for the problem number 1.171.